There are a group of people that absolutely and honestly believe in 2016 the Earth is flat. The Earth is flat.
First of all, lad, we've got to get all these medieval ideas out of your head. Clear the way for new ideas. Knowledge of man's fabulous discoveries in the centuries ahead. Now, that'll be a great advantage, boy.
Advantage indeed. If the boy goes about saying the world is round, they'll take him for a lunatic.
Fantasyland, the happiest kingdom of them all. Presenting this week. Here to introduce you to this new series is Walt Disney.
In our modern world, everywhere we look, we see the influence science has upon our daily lives. Discoveries that were miracles a few short years ago are accepted as commonplace today.
The world is round?
Yes, that's right. And it also goes around.
You mean it'll be round someday?
No, it's round now. Man will discover this in centuries to come.
Many of the things that seem impossible now will become realities tomorrow.
And he will also find that the world is merely a tiny speck in the universe.
A mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena.
One of man's oldest dreams has been the desire for space travel, to travel to other worlds. Until recently, this seemed to be an impossibility. But great new discoveries have brought us to the threshold of a new frontier, the frontier of interplanetary space. In this Tomorrowland series, we are combining the tools of our trade with the knowledge of the scientists to give a factual picture of the latest plans for man's newest adventure.
Universe?
You're only confusing the boy. Before you're through, he'll be so mixed up, he'll be wearing his shoes on his head. Man has always learned from the past. After all, you can't learn history in reverse. It's confusing enough, for heaven's sakes.
In working with engineers and scientists, we have found that there are many different opinions as to how we will eventually cross the space frontier. However, there's one point all of them seem to agree upon, and that is whether we use chemical fuels or atomic energy, it will be a rocket-powered ship that will finally take man into space.
9, 8, 7, 6, 5, 4,
Tomorrowland. Promise of things to come.
At Disneyland Park, the realm devoted to things of the future is called Tomorrowland. One of the popular attractions here is our simulated rocket trip around the moon.
The moon is a dead world without atmosphere, a silent, unchanging desert where temperatures drop to 250 degrees below zero on the shadow side and boil at over 200 degrees in the direct light of the sun. But uninviting as it seems to be, man's restless search for knowledge of the universe will certainly make the moon one of his first objectives in the exploration of space. To help show you what is being done to solve these problems, we have called upon one of the foremost exponents of space travel, Dr. Werner von Braun, who is at present the chief of the Guided Missile Division of the Army's Rocket Center at Redstone Arsenal. He was also overall director of the development of the original V-2 rocket.
The training methods for future space flight and the special equipment needed for survival are much like those of present high-altitude flying. And the experiments we are making today are helping us to solve the more complex problems to come. Take the present-day pressurized flying suit, for example. It has been designed for use at extremely high altitudes and is a forerunner of the suits we will wear when we make that trip to the moon. To give you an idea of how engineers and medical men are working hand in hand, here are a few examples of the research that's being conducted at this time. This pressure suit is being worn in a test chamber where the air pressure can be dropped suddenly. Notice that the water boils at this low pressure, even though it is only at normal body temperature. Blood would be the same without the protection of the suit.
Hey, Tim, it's really cool seeing that Union Jack go outside. This has explored all over the world. Now it's explored space.
Thank you, Scott. It's great to be wearing it.
Lieutenant Colonel John P. Stapp of the United States Air Force has subjected himself to the tremendous forces of a rocket sled that reaches a speed of over 632 miles per hour. The sled stops so quickly that Colonel Stapp's body becomes 35 times heavier than normal. From these tests, we have learned that man can take much greater acceleration forces than crew members of a rocket ship will undergo on a takeoff.
Slowly pouring more and more sand on your body as the vehicle accelerates.
We can see the limb of the Earth there.
In the void of space, he will have to wear a space suit. This specially designed outfit must be a flexible, airtight unit carrying sufficient oxygen. Featuring built-in all-purpose equipment, it will afford protection and maneuverability outside the ship.
He sees the Earth as a vast rolling sphere, upon which the oceans and continents are reduced to simple patterns of light and dark. Great cloud formations will appear as small patches of snow. Evidence of man's existence is almost invisible. Large cities can be seen only with the aid of powerful optical equipment.
Even though we now have the theoretical knowledge to make a trip to the moon, it will be many years yet before our plans can fully materialize. However, let us imagine for a moment that the many problems have been solved and that after completing our space station, we are ready to begin our first voyage around the moon.
Ladies and gentlemen, we are interrupting our program to give you the following message. Moonship RM-1, which left the space station a little over 51 hours ago, reports a distance of 169,000 miles from the Earth. The ship is traveling at 9,400 miles per hour, and deviations from the intended flight path have been so small that the captain reports no corrective power maneuver has been necessary as yet. We are happy to report all the crew are in good condition.
Yeah, you're just showing off now.
Let's switch it on. Let's see what it does.
Through this coil of thick wire, we're about to pass a huge alternating electric current. On top is a 1 kilogram aluminium plate.
So we hear this noise. What's that noise?
It's the vibration of the plate because it's vibrating at 2 times the frequency of this one.
Whoa! Whoa! How does it do that?
To find out, I've come to the place where it all started, the Royal Institution in London.
This is the key to Faraday's magnetic lab.
The navigator must now take a bearing on 2 fixed stars.
We also made use of the stars through the telescope in aligning a crosshair by rotating the field of view until the crosshair superimposed on the star. This would give us the angular measurement of the star within the field of view of the telescope. We then determine the distance out by aligning another reticle spiral on this. We went through an averaging technique on board and then fed this information into the computer, and this came up with our various alignment checks.
The next few hours will constitute the most important phase of the trip. The moon is sweeping past the ship at great speed, and in the brief span of about 3 hours, all close-up observations of its unknown surface must be completed.
Station 1. We are now seeing the Earth disappear behind the moon's rim. This will be our last radio message until you see us on the other side.
Roger, RM1. Good luck.
Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you. Roger out. Apollo 11, this is Houston. All your systems are looking good going around the corner. We'll see you on the other side, over. Roger.
RM1 to Station 1, do you read us, over?
Roger, RM1, we read you weak but clear, over.
At 123 hours, we are observing the Earth emerging from behind the moon.
Everything looks okay up here. Roger out.
For the past half-century, the intriguing possibility of traveling to Mars in a spaceship has challenged the imagination of many men. Rocket ships of all sizes and shapes have been designed, but most of them rely on an enormous consumption of chemical fuel to escape the pull of the Earth's gravity. A spaceship using an electromagnetic drive to neutralize gravity is the obvious answer, but such a device is still a dream for the future. However, at the present time, an atomic-powered spaceship has been suggested by a leading scientist in the rocket and guided missile field, Dr. Ernst Stuhlinger, who for some years has been working closely with the rocket engineer, Dr. Werner von Braun. This atomic electric spaceship features a revolutionary new principle that will make possible the long trip to Mars with only a small expenditure of fuel. Parts for the spaceship will be brought up to an orbit by conventional chemical fuel rockets. It will then be assembled in the vacuum of space. When our ship reaches Mars, the landing craft will be released, carrying men and supplies to the planet's surface. A drag chute will gradually slow the landing craft as it streaks into the Martian atmosphere. A few seconds before touching down, the main rocket motors will be fired and the craft will land gently on its nose.
LZ-1, the Falcon is landed. Landing operators moving to procedure 11.100, section 3 on LZ-1B-net and recovery net.
Later, the exploration party can return to the mothership by blasting off in the tail section of the landing craft.
Port stage pushed. Engine arm is descent. Okay, I'm going to get the pro. 99, proceeded. 3, 2, 1, ignition. Right away, Houston. Vector grid. Axot. Pitch over. Vector, you have good thrust. Okay, 30 seconds. 308 your number. Take up.
Liquids will be particularly annoying. They will not pour. They must be transferred by titration tubes.
It's really fun, Cody, yes. I mean, normally we have drinks bags like this, which have straws on them, and so we just drink all our drinks through a straw. But of course, you can have a lot of fun in weightlessness, and you can turn it into a bubble and then drink it.
Unless liquids are kept in leak-proof containers, they will escape and float in ball shapes around the cabin, finally coating all surfaces with a wet film.
And we were absolutely right. That is a sphere. You're going to try and drink that, Tim? Yeah.
To relieve the inevitable tensions of space travel, we must provide suitable recreation. The spaceman must learn to move with utmost caution. His muscles are adjusted to normal earthbound gravity. In space, any casual action will be violently magnified. He must coordinate himself under an entirely new set of rules. He can hardly avoid spinning constantly. When he crouches into a compact mass, he will spin faster. If he spreads his arms and legs, the spinning will slow down.
And start spinning, and then if you want to just keep me go round, and
keep you on axis.
Yeah, on axis, that's cool. Okay, if you want to stop me.
Yep.
After considerable practice, man will be able to master the art of swimming through the air within the rocket ship.
Or, if you want, you can go jump into the hole. I'm coming down. Woo! Then you can come right back up again, like Superman. Woo!
Sleeping will be a new and unique experience. A space traveler will not need a pillow or mattress. His bed will consist of a net enclosure to prevent drifting in his sleep.
This is my sleep station, my sleep pod. This is where I spend up to 8 hours every day, here on board the space station. It's actually on the floor, but once you're inside, you just can't tell.
Meteorologists will make studies for long-range weather forecasting. The science of astrophysics will welcome the clear views of our moon and planets, unhampered by atmospheric disturbances.
Say that the rocket falls around the Earth as long as it maintains sufficient speed.
Hi Tim, I'm Chloe from Golden Flats Primary School. My question is, why doesn't space have any gravity?
This might help me explain. You see, we're traveling around the planet so fast that as gravity pulls us down, we are missing the Earth. We're not actually hitting the Earth. And that's only because we're traveling so fast around the Earth that we're missing it, and therefore the gravity is pulling us down, but we never actually hit Earth.
But how does it maintain this speed with the motor shut off?
Remember, our rocket is traveling above the atmosphere, in space, where there is no air friction to slow it down. The rocket will have to go nearly 16,000 miles per hour, and will make a complete trip around the world every 2 hours.
The ISS, as it's referred to, flies at around 4.791 miles per second. That's 17,248 miles per hour. It completes nearly 16 orbits a day and is fast enough to nearly go to the moon and back in under 24 hours.
A few adjustments in its course will be necessary, but this can be accomplished from the ground by remote control, after which the rocket will continue to coast freely in space forever.
In other words, the rocket will stay up there just like the moon.
Yes, it will circle the globe as a man-made satellite.
What is the purpose of having this satellite up there?
Having this instrument-carrying rocket moving around the Earth will give us a lot of important information which we'll need before we dare let a man make his first trip into space.
Air friction begins to send the skin temperature of the rocket climbing until the ship glows cherry red at 1,350 degrees. The double hull and refrigeration keep the crew from perishing. The returning rocket continues the long glide down into the lower atmosphere, its temperature gradually dropping to normal as airspeed diminishes.
And when the shuttle re-enters Earth's atmosphere, the friction can cause those temperatures to soar as high as 1,650 degrees Celsius. That's 3,000 degrees Fahrenheit.
Wrapping up a 5.7 million mile mission to resupply and fortify the International Space Station. Tim Cobra home after 58 days in space.
Man has taken his first great stride forward in the conquest of space. His next goal will be the exploration of the moon, then the planets, and the infinite universe beyond.
Beyond the Earth, at the outer fringe of life's temperature zone, is Mars, the third planet in our solar system where life could exist. Even though scientists think Martian conditions are severe, they believe that if man journeyed to Mars, he could survive here with moderate protection. He would need his own oxygen supply and some sort of protective covering. But life could be almost normal within pressurized houses and pressurized cities. Today, as we face the serious problems of overpopulation and depletion of natural resources, the possibility of Mars becoming a new frontier is of increasing importance in our plans for the future. In solving the enigma of the red planet Mars, man may find a key that opens the first small door to the universe. Carried forward on the wings of modern science, man in the years that follow may discover the miracle of life as it exists in all its countless forms throughout an infinite creation.